We're in chapter 14 of distribution and storage of reclaimed water. So we've collected our water, our gray water. We've treated it to the proper regulatory agency standards. Now, what do we do with it? Well, we have to store it because your usage may fluctuate, like let's say you're storing it in a tank in the bottom of a high rise. Well, at night you're not going to have a lot of usage, but during the day you may have a lot of usage for that. So whether we're on a small scale, we're talking about uh, in a building, or we're talking about using it in a large scale for agricultural use, that's seasonal. So we might go from just a small tank in a building all the way to an open reservoir that we pump in all winter and summer and spring and fall in, and then we take that out when we really need it in the dry months. So it's really uh, needs to have a lot of forethought put into the storage, to the piping. Are we going to run it as a dual piping system, meaning that to the house, there'll be one line that runs to the back of the toilet for toilet flushing. That was gray washing unit, and then another pipe that goes to the sink. There's some additional cost there. And then what type of piping are we going to use? Is it going to be subject to corroding? Are we going to use copper? Are we going to use plastic? Is our system going to, it hopefully should have backflow protection. What type of, if it's an irrigation system, are we going to use a vacuum pressure breaker? Are we going to use an RPV Z, or are we going to do air gap, right? So we want to protect against back siphons and back pressure in our system because we are dealing with two sources of water that are so close together. The planning and conceptual design, once again, identify the reclaimed water users. So who are they? Determine the water quantities and the pressure requirements, the distribution system layout, the system analysis, and then optimization of that. I think that's on an exam, right? So you want to know who it is, how you're going to distribute it. Are you going to use the tree grid, the loop, or the tree system distribution, which you can see on page 836. The advantage of a loop system is that there is no dead ends. Um, in the grid, there's also very similar with no dead ends. A tree is just like you have your trunk and then your branches. Well, at each one of those branches, you could have a dead end line, which could cause the water to become stagnant. So a lot of times we want to make sure uh, that we can keep that water moving in on those dead end lines. It's important to have a blow off or a hydrant where we can open it up and flush the lines. You could get, I don't know how many do, but you could get as big as on page 839, you could a tank that size, actually have a water tower. I don't know how many actually have that when we talk about water reuse here in the states, but I'm sure in some places that they do. We talk about pumping stations. How are we going to pump the water, right? Like, are we going to use a split case centrifugal pump, um, or several of the other pumps that are, um, listed in the chapter? Working with an engineer and working with a someone who has designed a system designer that has designed water reuse as a on the infrastructure side would be really important. What type of fittings are we going to use? The location, the separation. Are we going to? There should be at least, it says, Reclaimed water may leak from reclaimed water, would have to travel at least 10 feet through soil before reaching a potable water line. So there should be in the ground, there should be some separation of those pipes. You obviously don't want them in the same uh, channel, and you want to follow some of the same uh, rules that we use when we have the crossing of wastewater and water pipes, right? Or we don't use ductile iron, steel, plastic, or you don't use push-on joints, mechanical joints. A lot of times, what I see as an operator is we don't really get to be much on the planning side. Usually, it's the engineers and the politicians, and they choose what we have, and then we just have to operate what they give us, which is fine. That's just the way life uh, works. But if you have a chance to actually work with them on the integration of some of these things, there's just many of things that you need to uh, come into consideration. 864 blow-offs and air releases are common components of reclaimed water distribution. Blow-offs are small pipe connections with valves located at dead ends and low spots to allow accumulative sediment to be cleaned by flushing. Releases are located on the high points of the distribution to allow trapped air and other gases to be removed. So once again, you need air releases just like you would in a wastewater system or any type of where you're pumping. But then blow offs also hydrants. They said they're not commonly found, but once again, I think it's not a bad idea to have it. All these should be labeled of some sort of non-potable reuse water, right? They should all be labeled so that everybody knows. Common sense here, your site elevation, the geography, your site layout, all these come into play. Just like on the distribution side, you don't need periodic flushing to keep the sediment out. Uh, you need your connection control, like I said before, your backflow preventers to make sure that water is not backflowing into from one source to the next. And then just as you would normally exercise in your valves, has some cathodic protection. Cathodic protection is basically to keep the steel tanks from corrosion, right? So there are products out there and managers for cathodic protection to make sure that your water tower is not corroding. I appreciate that's chapter 14. Thank you.